Hello all. Today I am going to explain the working principle of a brushless DC motor, commonly known as a BLDC motor. A BLDC motor is an electric motor that operates without using brushes or a mechanical commutator. Instead, it uses electronic commutation which improves efficiency, reliability and motor life. Due to these advantages, BLDC motors are widely used in electric vehicles, drones, industrial automation, robotics, computer cooling fans, and household appliances. The main components of a BLDC motor are stator, rotor, electronic controller, and Hall sensors. Let us see one by one. First, stator. The stator is the stationary part of the motor. It contains copper windings or coils arranged in three phases, usually named phase A, phase B, and phase C. When electric current flows through these coils, they generate a magnetic field. Whereas the rotor is the rotating part of the motor. It consists of permanent magnets with alternating north and south poles. The interaction between the magnetic field of the stator and the permanent magnets of the rotor produces rotation. Third one is electronic controller. The electronic controller replaces the brushes found in conventional DC motors. It energizes the stator coils in a specific sequence. This sequential energizing creates a rotating magnetic field that continuously pulls the rotor forward. The last one is Hall sensors. Hall sensors usually detect the exact position of the rotor. They send position information to the controller. Based on this feedback, the controller decides which stator coils should be energized next. Because there are no brushes, BLDC motor experiences less friction, which generates less heat, require minimum maintenance, and offer higher efficiency compared to the brushed DC motors. Next one is the working principle of the BLDC motor. The motor operates using electronic commutation method where the controller energizes different stator coils in sequence. In this case, as already we discussed, here three coils are available: coil A, B and C. Let us see step by step. You can visualize through the diagram shown in the figure. Step 1. The coil A is energized. This creates a magnetic field that attracts the opposite pole of the rotor. The rotor aligns itself with the magnetic field produced by the coil A. This is first step 1. And step 2. The controller switches off coil A and energizes coil B. The magnetic field shifts to the position of coil B. The rotor follows this new magnetic field and rotates clockwise. In step 3, the coil C is energized. Again, the magnetic field moves to a new position, causing the rotor to continue rotating. In the next step 4, the controller reverses the current in coil A. Reversing the current changes the magnetic polarity of the coil. This produces another magnetic attraction that keeps the motor moving. Similarly, in step 5, the current in coil B is also reversed. The rotating magnetic field continues to move around the stator. The rotor continuously follows the rotating field. At last, in step 6, the coil C is energized in the reverse direction. At this point, one complete electrical commutation cycle is finished. The controller immediately repeats the same sequence. Since this process occurs thousands of times every second, the rotor appears to rotate smoothly and continuously. The speed of the motor depends on how quickly the controller switches between these commutation steps. So let us discuss next about the advantages, applications and summary of the lecture class. Let us see first about the advantages. BLDC motor offers high efficiency because there are no brush losses. longer operating life due to the absence of mechanical wear and tear. So it requires very less maintenance only and produces very high torque with compact size, which leads to EV applications, that is electric vehicle applications. Quiet operation with reduced electrical noise and better speed control using electronic controllers. Provides faster dynamic response and improved reliability. In case of applications, it is widely used for electric vehicles, electric bicycles, and drones and quadcopters, computer cooling fans. Usually, computer cooling fans are offered with BLDC only, and industrial automations, robotic applications, and CNC machines. Sometimes in medical equipments also, uh, uh, in washing machines also, washing machines, that is household applications such as washing machines, air conditioners, refrigerators, power tools, etc. So all of these applications are widely used BLDC motor. As a summary, we can conclude that a BLDC motor operates by electronically energizing the stator coils in a precise sequence. The controller receives uh, rotor position information from through the Hall sensors and switches the current among the stator windings. So this creates a rotating magnetic field. So thank you for this humble listening, and we will continue the next topic in the coming sessions. Thank you.